All right, let's go through paper 2. Prelim paper 2. Okay, we got the questions. Where are the instructions already? We have some diagrams here, which are instruments. Question 1, 1.1. The images below represent measuring instruments used to measure mass and volume. Study the image below and answer the questions that follow. A, okay, match the descriptions below with the image above. Write down only the correct letter A to D. An instrument used to measure the mass of meat in the butchery. This has to be C, what we call the electronic scale. So this is C. All right, we go to an instrument used to measure mass of different food types in the kitchen. This had to be B. It's B. Then an instrument used to measure liquid. It's a jug, which is D. And an instrument used to measure body mass of a person. So this electronic body mass scale, which is A. So we have the answer supposed to be C. The answers were supposed to be C, C, B, D, A. We go to the second one, 1.2. The bathroom scales may be used to monitor one's body mass index. That's about a bathroom scale with a radius of 15. Define radius. We can say radius is half of the diameter. You know, for radius, we have different answers. Or someone can say it's the distance from the center of the circle to the circumference of the circle, like this. From the center to the end of the circle. That one would also be. So now they are telling us determine the diameter of the bathroom scale. Now, remember, radius is half the diameter. So if radius is half the diameter, what about diameter? Diameter means it's 2 times the radius, and which will become 2 times 15. And the answer here, you got it as 30 centimeters. Don't forget the units. This is paper 2, and we are looking at measurements. Convert 15 centimeters to meters. Convert 15 centimeters to meters. Remember very well that we are dealing with metrics. No one will give you the conversions here, but you know very well, changing from small to big, we shall need to divide. Small to big, we are dividing from right-hand side to left. So this is 15 divided by 100, and the answer becomes 0.15. These are meters. Don't forget the units. Let's measure that. Let's measured his height, and the reading is 66.929 inches. Determine the height in meters. They have already told you 1 meter is equivalent to. So if 1 meter gives me 39.37 inches, what about if I have 66.92 inches? What will they be? I call it B. So I cross multiply, simply meaning I will need to divide, which will become 66.92 divided by 39.37, and the answer becomes 1.7. answer is 1,7. Don't forget, these are meters now, from inches to meters. Yes, here I want you to remember that we looked at kilometers, meters, centimeters, and millimeters. Remember, in between here we have 1,000, here we have 100, and here we have 10. So that's where I got the 100 from, this 100 that I'm using here to divide. Okay, choose the letter of the answer that will complete the following statement correctly. The unit used to measure BMI is, it's B. Why do we say B? Because it's mass over height. But the height has to be in meters squared, and the mass has to be in kilograms. So this is per. So which is B. 1.3. Let's download the seating plan of a plane to check the seating, to check the seat that you reserved for a trip. Is the information in annexure A to answer the following questions. All right. When we look at the point, when they remember they asked us to give the okay. We are looking at what we call the, let's take it indicates that the person was seated allocated sixth seat in the east. Take note of that, in the east. So how will you know the east? We shall use what we call the compass and identify the seat. So let's go to the next chart. This is our next chart. This is the compass that we have. So when you look at the compass, it shows that this side here, this is the north. Definitely, the east has to be up there. This is, if this is the north, then the east is that side, then this is the west. So the east is on top here. So we need to count the step, the seats. We say 1, 2, 3, 4, 5, and 6. We are looking for the 6th place. So our answer there becomes 7, 8. Use the cardinal points where the toilet is situated. The cardinal point to determine where the toilet is situated. The cardinal point, when you look at the cardinal point, we are looking at north, east, west, and south. Cardinal points. Cardinal points. North, east, west, south. So in which cardinal point is the toilet? The toilet is here. So the cardinal point here is what? Because this is north, then the toilet is in the west. How many seats are on the plane? We go to the next chart. How many seats on the plane? Easy mathematics. Here we have, okay, this is our 6. So 7, 8, 9, 10, and 11. But how many complete like this? There are 3 of them. So when we come here, we shall say 3 times 11 plus 1. This one here. So it's 3 times 11 plus 1, which becomes 33 plus 1, which is 30, 34 seats. 34 seats. Then we go there and say, determine the number of single seats from this plane. The number of single seats. So these are the single seats. The number of single seats. Single seats. So what's the number of the single seats? So here we have 11. They are 11. We have it as 11. Single 6. What is the general direction? What is the general direction? What is the general direction? What is the general direction of seat 12 from seat 6A? General direction of, so we shall go there next year. Let's go to the next term. They're saying general direction of seat 12, 12A, seat 12A, seat 12A, room, room. So the person is in seat 6F, heading to 12A. So shall go to 6F. 6F is here. We draw a small compass. Remember, this is north. North, that's east, west, and south. So we are heading to 12A. So 12A. So this becomes northeast, becomes northeast, and we shall see that here. It's northeast. Express as a ratio. Express as a ratio. The number of double seats to the total number of seats. Now, since we saw that there are 34, since we saw that there are 34 seats all in all, let's remove the single seats. So remain with the 23. So we go for the ratio now. We say the number of double seats to the total number of seats. So it's 23 versus 34. 23 versus 34. That could be the ratio. Oh, sorry. Single plus the 12 one. There are 12 single seats, sorry. Remember, we have all these from up here. These are single seats, including the C. So they are 12, okay? 34 minus 12. 34 minus 12, we end up having 22. So it will be 22. 22, 22, 22, 22 versus 34. So by 2, you get 11. By 2, you get 17. That is question 1. Something sorry. We look at question number 2. Tandy lives in George, and she travels to Port Elizabeth, PE. She uses this map in an extra B to plan her local trips. Study the map and answer the questions that follow. What type of map does Tandy use in an extra B? Let's go to an extra B. Yeah. This map has a name. We call it a strip map. Others, instead of a map, they write a strip chart. Others can call it a route map. A route map. All right. We said it's called the strip map, or you can call it the strip chart. All right. Some other people call it the route, but this is the right word. So we're going to see, we write that there. So this is called the strip map. Which is the last city that she will pass before she reaches PE when traveling on N2. So this is PE. So that means she's coming from down, coming up. She passes this town, the last town before she reaches. So it's this one here, Human Drop. Name two regional roads that she will pass between George and PE when traveling on N, N, N2. This is the N2, the middle line here. This is N2. So we are looking for which, so between George, so George is here and P is there. Which regional route will she pass when traveling between, when she's on George and PE? So we have, there's this one here that turns off this side. She passes it before she, okay, also they have the 75 here. All right. This one here, it's route 328. Actually at George, this one here, the straight one. This one here. So this we shall say R 33, R 330, R 75, R 330. There was also, but they said two. So there was also R2 320, 328, this one here. Okay, it's fine. What is the distance between George and Port Elizabeth? What are we going to do? We shall need to subtract. Or remember, this map, one side, if it starts with 0, so from 0 to here, because George is on this line here. So we shall say it's 321 kilometers. For someone who doesn't know how we get it, you can use now. If you're to use numbers here we have 458 and 779. So which numbers we are going to subtract this? What's the distance between these two? So we shall say 779 minus 458. Indeed, you will get the answer as 321 kilometers. Can also use that. Okay, we go on. Turn the left George at 5:30 and reach PE at 8:25. 5 minutes past 8. Determine the time in hours taken to reach PE. So we shall say it's duration that we are looking at. Duration. So this will mean the end time or the arrival time minus the departure, the time when someone left, or the end time minus the starting time. So this simply means it will be 8:25 minus 5:30. In this scenario, it's too much. 25 cannot subtract 30. What do? We borrow from the 8, becomes 60. Now this one, 60 plus 25 becomes 85. 85 minus 30. You remain with 55. Remember here you borrowed 1, so you remain with a 7. 7 minus 5, you remain with the 2. So they said they want the time in hours. not minutes, hours. So what you're going to do, it will be what you're going to do, what you're going to do. So what you're going to do, remember we said it's 8:25 minus 5:30. The answer we've got it as 2 hours 55 minutes. They want the answer to be in hours. So this means it's 2 hours already. We change the minutes to hours. We divide by 50. So 2 plus 55 divided by 60. You end up having 2,92. These are hours. They said determine time in hours taken. They didn't say round off. Had they told us round off, it would be 3 hours. Okay, hence determine the average speed at which she traveled in kilometers per hour. Round off your answer to the nearest whole number. Now remember, this is a confusion. They have told you to find speed. Speed, it's this one here. So in your head, you already know that speed equals to distance divided by time. So we already have the distance as 321 divided by now time, which is 2,92. It's the speed, which will become 321 divided by 2,92. So she was traveling at 109,93. Remember, they said round off your answer to the nearest whole number. So this becomes 110. Don't forget the units, kilometers per hour. That's what we are looking at. 2.7. Tandy claims that the shortest route from Worcester to Muscle Bay is the national road instead of the regional roads. Verify using calculations. Now, we are going to look at two distances. We shall compare the distance using the national road, which is the N2. It's going to be the N2. All right. Actually, even this one's N1. National roads. Or we use the regional roads. The national roads, we shall say these are the ones. The distance from here, that's what we are looking at. The distance from here, then we move up to when we reach Muscle Bay here. Or we shall use the distance with routes, which will be this, turn, come here, then the remainder is supposed to be here because that's the other way. So the green route, it's the regional routes. Then the red, it's a national route. Let's continue with say. Now, we continue to say, so I want you to get, we're going to compare distances. So first and foremost, I must start with national, 2.7. When you use the national road, which stations are you going to use? So it's on N1. We start at N1, we start at this place here. The distance from here up to there, it's 46. From here, Pearl, to here, it's 51. Now, the distance from here to Muscle Bay is 394. This is the distance. Now, this is when you've used the national roads, the N1 and N2. What about if you've used the regional roads? That simply means you start from here to there. All right? From here to there. So if you are to use the routes, the regional routes, so meaning we shall start from here to there, then from there to this other part here. There's no there's no route that goes direct to Muscle because Muscle Bay is on N. It's on the national road. They definitely have to use the regional roads inside. Then when you reach the national road, you complete this other distance that's remaining together. So here, simply meaning, we shall start with 50 plus 29 plus 146. 146, it covers the distance from here and the corner then. Then we add on, 146. This 45, it's from here going up, but we shall not go up. 45 is in between there, but we shall not go up that direction. We are just going. So we are continuing this other side. So 146 plus 82. Definitely 82 pushes you to the end. And so what's the distance from here to there? So which we shall say we subtract 394 minus 304, whereby we get 90. So we shall also add here 90. So the national road, if you're to use the national road, we have used 46 plus 51 plus 394. So you end up having 491 kilometers. This is the distance moved on national roads. What about the regional routes? So here we are saying, we said it's 90 plus the 50 plus the 29 plus 146 plus the 82. What answer do we end up having? The answer, we have it as 397 kilometers. So remember, the claim was, Tandy claims that the shortest route from Waterloo is by national road. So we are verifying. You understand? So it's incorrect. It's incorrect. Allow me break it down. We are saying from Watches you go to Pearl, then from Pearl you go to Cape Town, then from Cape Town you go straight to Muscle Bay. But then the distance we found out, there were distance between these two towns, it was 46. That other town, Pearl to Cape Town, 51. And then on N2 we have 394. At the end of it all, we have moved. Remember, this is on the national N1 and N2. Then we verse them with the regional roads, which is these ones here in green. Watches through Robertson, then we go to Matangu, then we turn to, we turn to Riversdale through Ladysmith. All right. So we shall do that. We say Wordsbell and then Robert. Then we go to Mtang, and then we go to Mtang, then it goes to Ladysmith, and Riversdale. So the distances we saw in between here, they were from there to there, we have a 50. Then from Robertson to Mtango, we had 29. Mtango through Ladysmith, we had the 146. Then plus 82, which is Ladysmith to Riversdale. Then at the end, we add on the 90, which was from Riversdale to Muscle Bay. So we got our answer as 397. 397 97. So if you have the answers 397 kilometers. So these are the regional roads. The regional road. So the claim is what? The claim is invalid. The shortest route is when you use the regional roads. He said, give one advantage of using this map. The advantage of using this map would say it's more detailed, né? Since it's small. So they will try to, and it's straightforward. More, can say it's more detailed, easy to interpret, easy to interpret. No? We look at question number 3. That was preparing for a picnic. He cuts a drum into 2 pieces to design a braai stand as shown in the diagram below. He cuts, this is what we call the drum. All right. Then after cutting it into 2, he remains with half of the other, this one here, to make a braai stand. Okay. So the diameter of the drum is 1 meter and the height is 160 centimeters. The top of the braai stand will be, there will be a rectangular grill, which we will put with dimension A and 1.7 meters. The width of the braai stand top is similar to the diameter. And we shall say they say the braai stand will be half filled with concrete mix, not mixture, mix. Okay, there we go. So what is the value of A? Remember up here they have told you the value of A, the dimension, we are looking at A, and they say the width of the braai as a similar, is similar to the diameter. So the width, which is the A, because the length is 1.7. The length is 1.7. What about the width, which is here, which is the A? So we shall say our A will equal to 1 meter. Okay, calculate the area of the top braai stand and round off your answer to the nearest whole number. So they said, first and foremost, they'll give us a formula. You substitute, the length is 1.7 times, the other one it's what? 1, which becomes 1.7 meters what? Squared. But they said round off to the nearest whole number. So this becomes 2 meters what? Squared. Okay, 3.3. Use calculations to show that the length of the top extends by 0.05 meter on each side. All right. This is a little bit not that hard. It's just logic. Let's look at it and we see what we mean by that. Which color can we use? All right. From here, this is from there, from here to there, it's 160 centimeters. You understand? But the top part of the grill, it's 170 centimeters. I've changed this to centimeters, so you get the answers 170 centimeters. So now, if the braai stand is smaller than that means the grill is longer than the braai stand, which is okay for safety and stability. Because imagine if it was exact 160, it will either the grill will fall inside the fire, or actually it would fall inside the fire. It will not have that standing part of it. Okay, so now here we go. We shall say 170 minus 160. What's the answer? We remain with the 10. These are 10 centimeters. So we need to divide it equally on both sides. So simply meaning we divide by 2. The answer becomes 5 centimeters. We don't want centimeters, we want meters. So we divide by 100. So the answer became 0.5 meters. So you've proved it. We are doing question number 30.3. I was trying to explain it in a logical way. Right? That is it. Another way how you would have done it, it's that still we change the 160. You say 160 divided by 100 comes 1.6 meters. 1.6 what? Meters. Then we subtract 1.7, which is the braille stand, which is exceeding the length of the braille stand, which is the length of the grid, minus the length of, which gives you 0.1. These are already meters. So what do? We divide by 2. And the answer becomes 0.5 meters. Same story. Hence, calculate the capacity of the drum. Now, capacity of the drum, I've told you capacity equals to pi r squared h. Don't forget, do you have, because the formula says, find the capacity, and it says pi r squared h. So do you have pi? Yes, 3.142 times. Do you have the radius? No, we only have the diameter. So the diameter will become radius. Radius will be diameter divided by 2. The diameter, it was 1. So we have 0.5. Come and substitute it here. Times the height. The height, we've already changed the 160 centimeters, change them to meters. You have 1.6. So you come here, put 1.6. So 3.142 and 0.26 squared times 1.6. This is meters what? Don't forget it's in meters cubed. Meters cubed. Someone else would have changed it to liters, which simply means you would have calculated it in a in centimeters to make a clear picture. Now here we go. Determine the volume of the braille stand that will be half filled with concrete mix. So the volume equals to, same story, pi r squared h. However, now it's a half. So the volume will be by the way, you can, let me see here, they said, no, here they say the capacity of the drum. That's a full one. Then here, the braille stand. Now remember, the braille stand comes from the drum and it's already half. So it will still be the same, which is 3.142. We multiply. I will do my, all my numbers will be in centimeters. So this is 50 centimeters squared times the 160. times 160, 0.142 times 50 squared times 160. So the volume we have it as this centimeters, what? Okay, but because it's a half, we need to divide by 2. Divide by 2 and becomes centimeters cubed. If it's needed in meters, centimeters to meters, we divide by 100 cubed. Divide by 100 cubed. Which will be 0.6284 meters, right? Cubed. Okay, now we go to question number 3.6. Remember, up there we've already got the answer as the this was our volume in the meters. Meters cubed. So here we go. Here we go. The concrete mixture, the concrete mix is sold strictly in wheelbarrows at a local hardware store. Take note of the following. 1 meter cubed, it will take, or it will need 20 wheelbarrows. Then the cost of 1 meter cubed of concrete mix is 1,800. 1,800. Use calculations to determine whether the cost of the concrete mix needed have to pay the price stand will be less or more than 300. All right. So now this is the volume. All right. The volume of the half the tank. Half the tank. But then the concrete is also going to take a half again. So meaning we need to half this volume again. We divide again by 2. So we divide this by 2. So this will be the volume to be filled with the concrete. Volume to be filled with the concrete. So it's cubed. So we find out how many wheelbarrows do we need for this. So this, and actually, you just need to multiply by the money because we are proving the money. Because these are the, it says 1 meter cubed, one pays. So what about for 0.3142 meters cubed? So the person is going to pay 500. So the money is more than, it's more than 300. Look at question number 4. Look at question number 4. Tepo is planning to travel from Centurion to visit his family in Soweto. He studies a map as he is a new driver. Study the map and next just see and answer the following questions. Question 1, name the type of scale that is used on the map. Let's go to the annexure. Now, when you look at it, this is the map. Let's just see. So they're asking which type of scale is it? There's this scale here. And this one we call it a Pascal. So the type of scale that we have here is it's a Pascal. Name the neighboring provinces found on the eastern and the western sides of Gautrain. So we know very well this is the north. This is north, and then this is east. This is west. So neighboring provinces, here we have Pumalanga, and here we have northwest. So you can say eastern. Eastern, it is Pumalanga. Pumalanga. And western, in the west, it's the northwest. Use the given scale to calculate the actual distance between Centurion and Soweto. Actual distance between the actual distance between, so the actual distance now simply meaning you need to measure the distance. First, you're going to measure the distance between Centurion and Soweto. You use the ruler on the side of millimeters. Measure the distance between we shall measure the distance between it's approximately 52 millimeters. All right, approximately 52 millimeters. Then, since we are measuring, now this is not the actual, this is a measurement on paper. So after that, we come down here and we also measure the sector we shall measure from here to there. Only this. So this is approximately 10. So you've measured the scale. So now, what scale are you going to use? It simply means if you have 10 millimeters, you have an equivalence of 15 kilometers. However, I got the kilometers, they are telling me, allow me use the map because they don't have space. So the scale, so the scale, it's 10 millimeters are equivalent to 15 kilometers. But for you, you've measured the distance between Centurion and Soweto, it's 52 millimeters. What will it be in real life? So what do we do? Cross multiply. We don't know this distance. So it will be 10 h equals to 15 times 52. Because you're looking for h, you divide through by 10, divide through by 10. And the answer becomes 780. You divide by 10, the answer becomes 7. That's how it's supposed to be done. The reason why I didn't convert this study in kilometers, and in actual sense, the distance has to be kilometers. So that's done. Let's continue. Let's continue. Okay. Still on the map. Here now we found out that we have 78. What? We have 78 kilometers. Hence, simply meaning, basing on 4.1.3, use this to determine this. Now they say, hence determine the number of liters of petrol required to cover a return trip if consumption rate of Tsepo's car is 0.086 liter per kilometer. You see that? Now, what I would like you to understand here is that they have talked of a return trip, simply meaning going and coming back. So you're going to get the distance, multiply it by 2. The distance, multiply it by 2. So what is the distance covered there? It's 156 kilometers. Now, for only 1 kilometer, you spend this much liters. What about if you have 156? So we shall need to multiply by 0.086. Should need 13.42 liters of petrol. 4 liters of petrol. What is the probability of finding a toll gate in the southeastern side of Johannesburg? Express your answers as a percentage. Let's go and we see. First and foremost, you have to identify the southeast of Johannesburg. This is Johannesburg here. So southeast is this side. How many do we expect to see? We have 1, 2. So the probability will be 2 out of how many are they? We have 1, 2, 3, 4, 5, 6. There are 6 toll gates all in all. 6 toll gates all in all. So divide by 6. But they want it as a percentage, multiply by 100. So it's 2 divided by 6 times 100, which is 33.33. Don't forget the percentage. We repeat, probability as a percentage. We said there are only 2 toll gates in the southeastern part of Johannesburg. Then, but how many toll gates are they all in total? There are 6. But they want the answer to be as a percentage. We multiply by 100. And the answer, we've just got it as 33.33%. Okay. Typo decided to pave the swimming pool area of his family home in Soweto. The shape of the swimming pool is a square with each side 9.84252 feet. And they have told you one foot is equivalent to 0.3048 meters. And the area of the backyard where the swimming pool is situated is 7 meters by 5 meters. So it's a rectangle. So there we go. Convert the side of the swimming pool to meters. So they've told you, if I have 1 foot, I have 0.3048. But these are what? Meters. But now I have more than 1 foot. Definitely, it's going to enlarge. So it's going to be 9.84252 to feet, we need it to become meters. I'll call it letter B. So I cross multiply. So my B now will be, my answer here has to be 9,84252 times. We are supposed to multiply. The reason why I have a B here is because 1 times B, you get B. That's straightforward. So 9,84252 times 0, not 2 over, not over 4, like water spilling, you know. Then yeah, even when someone dives in, they should not, the water should not overflow. The water should not flow out of the swimming pool, not overfilled. You understand? And the principle of physics says the body mass, a body mass in a fluid displaces an equal volume of water. Explain the difference between capacity and volume. Now, what I want you to know, capacity is how much can be, this is what, contained. How much can be contained in a given object or given container. Then volume is the space available. The space available. Now here, in this context, we shall say capacity, it was the word, how much water can the swimming pool take? You get that? Then volume would be how much space is in the, how much space does the swimming pool take? When it has no water, how much space is it? You understand? Okay. Determine in meters squared the area of the backyard that will not be paved. Take note, that will not be paved. Let's go back to the diagram. Now, area that will not be paved. The area that will not be paved. Remember they said Zepo wants to pave. Zepo said to pave the swimming pool area of the family house in Soweto. The swimming pool area, that says. So there's a certain part that will be, but this, the area that would not be. So here it's simply meaning we are going to subtract. So we shall say the area of the yard, which is the backyard, which is 7 times 5. You get 35 meters squared. And the area of the pool, which is already 3 times 3, becomes 9 meters squared. Subtract the 2, 35 minus 9, you end up having your answers 26 meters squared. Question number 5. Tipo lives in Pretoria and travels daily to work in Rosebank using Gautrain. Is his reporting time In other words, the starting time. The login time is supposed to be 8. He has to be at work at 8 every day. He walks for 10 minutes to his workplace from the Rosebank. Definitely Rosebank. The place that he works in is Rosebank, but walking from where? The Rosebank, what? The Gauteng station, Working from there to then study the Gauteng timetable study the Gautrain timetable in the next year and answer the following questions. So what we're going to do is 5.1.1. Which train, southbound or northbound, must he take in the morning to work? Explain your answer. Let's go there and check their mixture. Now, remember, he lives in Pretoria. He lives in Pretoria. He works in Rosebank. So, what are we going to do? When we look at this one here, it's departing from Park Station to go to Rosebank. It goes to Santon, Marlborough. Then afterwards, it's in Pretoria. And it's in what? Hatfield. That means this one is coming from Park Station. Remember, for him, he stays in Pretoria. So definitely, yes, because this one's departing from Pretoria, heading to Rosebank. You see that? So the train that is going to use, it's Southport. Because it runs from Pretoria. Southbound because it runs from Pretoria. Southbound because it's from Pretoria. What is the latest that he should depart from Pretoria if he wants to be at work on time? Remember, he has to be at work at exactly 8. Definitely cannot get a train that will drop him at exactly 8 because he has to walk 10 minutes. That means he will reach 10 past 8. So for him to catch a train, the train that he should take he should arrive at Rosebank before 8. Let's go and see. Now here the trick is we've chosen the train as this much. So it's from Pretoria to Rosebank. So we shall come to Rosebank and we look for the train that has, because this one it's no, because it's already past 8. This one never. So it's supposed to be the train. So this train here is this one the other, because now this one it will arrive at Rosebank at what? At 7:49. So it still has 11 minutes to 8. You see that? But remember, he has to walk 10 minutes. So 11. So he has 1 minute to spare. You understand? So they are saying the latest. So which to depart from Pretoria. So we shall go and see that train. When does it depart from Pretoria? It should depart at 7:18. So you should leave Pretoria at 7:18. This is when he's panicking. Here you'll be rushing because he has to beat the time. Calculate the duration of Sipo's journey to work, including the walking time. what shall do is that the duration now it will be, we say 7:49. That's when you arrive at the bus station. Then minus, we want to know how much time has he spent on the train. So there we go. He has spent around 49 minus 18. He has spent 31 minutes. You see that? 31 minutes. Then on top of the 31 minutes, we add on the walking time, which will be 41 minutes. Give two advantages of Gautrain. One, it's safer and it's fast. It's safer than our metro trains. Okay, the average temperature in Pretoria is 30 degrees Celsius. Convert this temperature to Fahrenheit. All you do, where you see the C, you put the 30, substitute in the formula. So it's supposed to be 1,8 times 30 plus 32. So we get the answer as 86 degrees Fahrenheit. 86 degrees Fahrenheit. $80 degrees Fahrenheit. So I, can after can, MN, JF. F during T breaks. He used a tree diagram to explore the possible options of snacks. Study the tree diagram in the next year E and complete it by writing the correct letters next to Roman numeral 1 to Roman numeral 3. Okay, let's go and we see their next year there. Here we go. Yeah, this is what we call the tree diagram. These are the possible outcomes. So I, remember we are giving answers for I. This one here, what could be the answer? Now, this is N, and indeed there's N here. That means this M came from here. So our I, it's M. We go. So Roman numeral 2. Roman numeral 2, we have JN. We already have J. That means this is what? N. Roman numeral 3, which is, we are going to take J and F. So this is JF. So it was MNJF. MNJF. All right. Sipper bought canned fruits and he must pack the cans in a plastic container. The dimensions of a can and the container are shown below. All right. The can is a cylindrical, it has diameter and height, and the container there it's rectangular. So this takes us back to packaging. To mail advise people to pack the cans upright so that he can pack 1,134 cans in the container. Verify his claim. So first and foremost, you're going to look for how many will fit on the long side. If they are, because if it's to be packed upright, it's going to be one can, the other can. Then also we go on top, can after can. You understand? So we want to know how many cans will they be? How many cans do we need here? You know, this is this is what it means, being packed upright. The cans are going to face up like that. But we need to know how many will they be. Okay, so what we're going to do, we shall say number of cans on one, we shall say on the long side, which is the lengthwise, on the long side. So if we want to find out how many will they be here, so we shall take the length of the box, the container, divided by the diameter of the can, which will be 126 centimeters, divided by the diameter, which is what? 6. So this is approximately 21. Those are 21 cans. So on the long side, we shall have 21 cans. 21 cans. So what about on the short side, which is widthwise? On the short side, we shall have the width of the box or the container, this one here, the rectangular, divided still by the diameter of the can. So let's go and we see. The width of the container is 53. So 53 divided by 6. 53 divided by 6. We have 8,83. And continue. Now, this simply means even though it's 8, when we round, because these are cans, you can't have half a can. You understand? So you're supposed to have a whole number or a big number, a number. So this simply means, yes, 8 feet exactly. But should you try to force in the 9th one, it won't fit. So we have 8 cans on the short side. So what about the layer wise? Because the only one layer has, the first layer has 21 times 8, which is approximately 168. 168. So what about if you have to pack them on each other? How many cans will they be? So we are looking at number 3. How many layers are we going to have? Layers, we shall see. We shall take the height of the box divided by the height of the can. So the height of the box, let's remind ourselves, it's 72 and the height is 12. The height of the can is 12. So 72 divided by 12. 72 divided by 12. We have the answer as 6. So these will be layers, not cans. Each layer will be holding 160. So all in all, how many cans do we have? 168 times 6. We have 1008 cans. So the claim is what? It's invalid. The claim is invalid. This marks the end of our question paper. This marks the end of our question paper. Thank you very much. Bye-bye.